Hello and welcome to today's episode, where we're diving deep into the world of real-time machine learning applications in 2025. It's a fascinating topic, and one that's incredibly relevant as we see more and more businesses and technologies integrating AI into their everyday operations. Now, let me take you back a bit. Just last month, I watched a team make the same mistake I did 5 years ago. It's one of those situations where hindsight really is 2020. And it serves as a reminder of how important it is to understand not just the tech itself, but the context and timing of its application. The landscape of machine learning has evolved dramatically since 2020, and yet some of the core challenges have stayed remarkably consistent. It's a curious thing. We've seen organizations invest millions in the latest GPU clusters and the most sophisticated transformer models. But, and this is a big but, they often stumble on basic infrastructure decisions. It's quite ironic when you think about it. Our algorithms are more advanced than ever, yet the foundational principles of building reliable, scalable systems are just as crucial as they've always been. Let me share something important here. It's not just about the algorithm. This is where many people get it wrong. They focus too much on the algorithm itself and not enough on the infrastructure that supports it. Sure, algorithms are essential. They're the brains of the operation. But if you don't have a robust and scalable infrastructure, even the most brilliant machine learning models can struggle under real-time demands. Ever wonder why some applications run seamlessly while others lag, even if they have similar models underneath? It usually comes down to the infrastructure, which is often overlooked. Imagine building a Formula One car and then expecting it to perform on a dirt road. That's exactly what happens when you don't have the right infrastructure in place. In today's real-time machine learning ecosystem, a holistic approach is crucial. We're dealing with microservices architectures, containerized deployments, event-driven systems, and distributed computing, all while maintaining sub-second response times. It's a complex dance, and it requires careful planning and a deep understanding of how each component interacts with the others. Let's start by talking about data. In my 12 years working with machine learning applications, data bottlenecks have almost always been a major culprit of failure. Your data pipelines need to be optimized not just for volume, but for velocity and variability as well. We're talking about data streams that can fluctuate wildly, and your system needs to handle that without missing a beat. This is where the concept of data mesh comes in, a decentralized approach where domain teams own their data products. Instead of relying on monolithic ETL processes, we're seeing more event-driven, streaming architectures that can handle real-time data ingestion, transformation, and serving simultaneously. Now, let's pivot to edge computing. This isn't just a buzzword, it's a real game changer. By processing data closer to where it's generated, such as on sensors or devices, you can significantly reduce latency. This is especially important for applications that need immediate insights, like autonomous vehicles or smart cities. Imagine how much faster your application could be with less back and forth to the cloud. The reduction in network latency can be astonishing, often shaving off milliseconds that can make all the difference in performance. Another vital aspect to consider is hyperparameter tuning. This might seem like a small detail, but it can drastically affect model performance and efficiency. It's not just about setting parameters, it's about unlocking hidden potential. Automated machine learning platforms have revolutionized this space, making sophisticated hyperparameter search accessible to teams without deep optimization expertise. It's fascinating how these tools now integrate with MLOps pipelines, enabling continuous optimization as new data comes in. And one more thing you shouldn't overlook is continual learning. Models need to evolve to stay relevant, especially in dynamic environments where data patterns shift constantly. Continual learning allows your systems to stay ahead of the curve, adapting to new trends without needing to start from scratch every time. It's the difference between having a static snapshot of intelligence and a living, breathing system that can grow and change with the world around it. Finally, perhaps the most crucial point. Make sure your system is designed for scalability from the very beginning. This isn't something to tack on later. It's a core principle. Cloud-based solutions offer the flexibility to scale up or down dynamically, adapting to changing workloads effortlessly. This means building for tomorrow's demands, not just today's. In 2025, scalability means thinking beyond traditional scaling methods. We're seeing the rise of serverless ML inference platforms, auto-scaling Kubernetes clusters, and intelligent resource allocation systems that predict demand patterns. So, to wrap up, implementing real-time machine learning applications in 2025 is about going beyond the algorithms. It's about understanding the intricate dance between data, infrastructure, and the latest in edge computing. It's about tuning and evolving your models continually and ensuring your systems are ready to scale at a moment's notice. By focusing on these aspects, you can avoid the pitfalls that others have faced and truly leverage the power of machine learning in real-time applications. Thanks for joining me today. I hope you found these insights helpful, and I look forward to diving into more exciting topics in our next episode. Until then, take care and keep exploring the fascinating world of AI.